Okay, so here's an audio on the outer gas giants of our solar system. Now, you're probably well aware that there are 4 inner planets, which I covered on the first video, and now we're going to cover the 4 outer gas giants: Jupiter, Saturn, Uranus and Neptune. So if we start with Jupiter, Jupiter orbits the Sun in 11.86 Earth years, at an average distance of 483 million miles, a tremendously vast distance. I'd just like to say, please ignore these blobs on the screen here. These are just to earmark the asteroids, which I'll probably cover at a later date, as well as this blob here, which again is another blob of asteroids, literally. Now, Jupiter itself is the biggest of the outer gas giants. And it also has 63 moons, a faint ring and an enormous magnetic field. Despite the actual size of Jupiter, it manages to rotate in just under 10 hours, which is very, very quick for it to turn around on its axis for such a huge planet. A quick fact about all of our 4 outer gas giants: each one of them has a very, very small inner rocky core, which is very tiny in comparison to the 4 inner planets. But still, this just proves to show that if they actually didn't have cores, so to speak, they wouldn't be able to attract the amount of gas that they would have had. And the main gases that contribute each of the 4 outer gas giants are hydrogen and helium, 2 of the most simplest elements in the whole of the universe. And actually, it is these 2 elements that make up every single star that you see, whereby they are fusing hydrogen into helium. So, in a fundamental nutshell, each of the 4 outer gas giants are failed stars. Obviously, the amounts of each change. The one with the highest ratio is actually Saturn. Saturn has a ratio of 96% hydrogen and 4% helium. Next we will move on to Saturn. Saturn itself orbits the Sun at a distance of 886 million miles, and it actually takes Saturn a whopping 29.46 Earth years, call it 30 Earth years, it takes for Saturn to orbit the Sun. Saturn is mainly famed for its amazing and beautiful ring system, which again I could go to in great depth in another video. As I've just said, the composition of Saturn's atmosphere is mainly hydrogen and helium like the others, but it is the most. The other gas giants, Jupiter, Uranus and Neptune, all have a partial composition of methane in their atmosphere, which may seem very, very strange, but this can also affect the actual colours of the planets, particularly the outer 2 of Uranus and Neptune, which are famed for being ever so slightly blue. This is due to the methane present in their atmosphere. Next up, we will move on to Uranus, which takes 84 Earth years to complete one orbit of the Sun. So you're probably gathering that the further we move away, the longer it takes a planet to actually orbit its star. And Uranus actually orbits at a distance of 1.8 billion miles. You're probably noticing as well that the distances between all of them, that is a distance between Jupiter to Saturn, Saturn to Jupiter, Uranus to Neptune, is gradually getting bigger and bigger and bigger. There is no real average, so to speak, that you should be orbiting a star. It's just literally where they fell. Neptune itself is often referred to as Uranus' twin in many ways, as it is almost the same size and mass. Again, it has a thin, dark ring system, much like Uranus. In fact, the one thing I didn't really touch upon with Uranus is the planet itself is tilted onto its side, which again I could do a whole other video on that completely, but that's what makes Uranus that little bit different. If you can imagine that, sorry about that, if I can draw, most planets are relatively like that. Like the Earth has a slight axial tilt there of 23.5 degrees. That is a North Pole, that is a South Pole. Uranus, although it may look like that, the poles are actually there. So it is tilted perfectly onto its side. Now, lastly onto Neptune. Neptune orbits the Sun in 164.8 Earth years, and it's actually just managed to complete one full orbit since it has been discovered. So that is, since we actually discovered Neptune, it has now managed to complete one full orbit around the Sun. And the whopping distance between the Sun and Neptune is an average of 2.8 billion miles. So when you consider that the Earth is only 93 million miles away, that is still a huge distance that we can't possibly comprehend. The distance between Neptune and the Sun is absolutely ludicrous. And to think that we can actually see Neptune, it's awe-inspiring, really. It really is. In principle, that is fundamentally it, to be perfectly honest. That's just a rough guide about the distances between our star and these outer gas giants, their composition, how long they take to orbit the Sun, the speed at which they do so, how long it takes for them to spin on their axis. You know, it's a beautiful world out there that we have discovered. I guess another final thing I could discuss would be the moons of each of the outer gas giants. The moons are more abundant around each planet than they are on the inner solar system. As I did briefly say, I think Jupiter has 63. Saturn has, I think it's roughly about 61. The Uranus has, I would have to double check, I'm afraid, but I think it's roughly about 13, and Neptune has about the same. Don't quote me on that, I'm having to go off the top of my head there, but I think that is roughly right. If I have to correct that, I will do in the next video. Thanks very much.